So what we have here, guys, is we have express the following fraction in its simplest form. Okay, so express the following fraction in its simplest form. Now, if I gave you a really easy fraction to do, something like a half minus, I don't know, a third, here's what you do. Without using your calculator, of course. Half is be reaching for your calculator. Okay, what you're going to do is the 2 looks across at the 3, and what it does is it goes, I could do having the number 3 beside me, so it goes 3 top and bottom. If you multiply a fraction by the same amount and divide by the same amount, does it change the value of the fraction? No. So we're multiplying by 3, but then we're dividing by 3, so it remains unchanged. The 3 then looks over, and what does it see? It sees the 2. So it's going to be 3 multiplied by 2 multiplied by 2. Now all of a sudden you're going to get 3 over 6 minus 2 over 6, and the answer is 1 over 6. Now, these fractions above are absolutely no different. They obey the exact same rules as the other ones. An example would be 34 part 4. 6 over x plus 6 over x plus 2. The x looks across, and what does it see on the same level as itself? It sees the x plus 2. What you do to the bottom, you must do to the top. Likewise, the x plus 2 looks over, and what does it see? So what you do to the bottom, you must also do to the top. Now, 6 times x plus 12 plus another 6x, and then all on the bottom is what denominator? You can do x squared plus 2x, that's okay, yeah. Higgins multiplied it out and just left it on the bottom. See the way it's like a 6, it stays the same. So now what you do is you look in and you go, okay, what can I do here? The 6x's add together to give you 12x plus 12. On the bottom we have plus 2x, and there's not much we can do. We can factorize out. We can say, look, it's the same thing as 12 into x plus 1. Everybody saw where I got that? Then we can undo what Higgins did a second ago, and we can say that's x into x plus 2. But we can see nothing can cancel. You need an x plus 2 on the top to cancel, so nothing can cancel. Okay, so you're safe. That's it, you're done. That's your answer. Okay, let's try another one now. I'll just group this here and keep it. There you go. Now you can see it all. Now, do another one. Another example of doing one of them would be the likes of part 5. 1 over 2x minus 3. Take away 1 over x plus 3. Any ideas how to do this? By x plus 3. Excellent. And then the other one. 2x minus 3 on the bottom. Okay, and on top. The bottom part of the other side, yeah. Okay, now what's next? 1 by x plus 3. Take away. Now that's a minus 1. See the minus here, guys? That minus, if I can grab it, belongs to the minus 1. Belongs to the top part always, okay? So what happens when you multiply m by minus? Plus 3. All divided by, we don't need to multiply the bottom out, by the way. Doesn't matter which way I put it. Doesn't matter if I put down x plus 3, 2x minus 3, or does it matter if I put 2x minus 3 first and x plus 3 second? Why does it not matter? It's multiplication. 2 multiplied by 3, same thing as 3 multiplied by 2. Okay, what happens to the top? Minus 1x and 3 plus 3, 6, and then on the bottom x plus 3 and 2x minus 3. So that's your answer for that one. Everybody okay with these ones? Okay, I reckon you'll give them a good go. Now, likes 35, a show that question, okay? What does a show that question usually mean? It means that the left hand side will have to equal the right hand side. So an example would be I have 35 part 1. What I have here is the left hand side. Left hand side's in the red box, right hand side's in the blue box. Choose one of them to work with. You usually choose the bigger, more complicated one. In which case would that be the red or the blue? Red. You'll choose the red. So we're going to work with the red box, okay? So we're going to work with this one here. 1 over r minus 1 minus bracket 1 over r plus 1. Like last time, what did we do? R plus 1 top and on the other side top and bottom, and then long behold, look what happens. R plus 1 on top, yeah. Where that minus, where does it belong? To the top. And then minus r plus 1, okay. And then underneath, multiply it out, r by r by minus 1, 1 by r, and then 1 by minus 1. Now, look what happens. R minus r on top, 1 plus 1, 2. Minus r plus r cancels, and then what do we have left? Has the left hand side changed into the right hand side? I've changed the red box into the blue box. I've proved it. Proven. Is that okay? Okay. Now, you might go a bit further. Leave that there, will I, for a minute? Okay. Yeah. Yeah. Fully intended. So, yeah. That means r can't be equal to plus or minus 1. Now the reason why, you'll see that a lot. See the way it's 1 over r minus 1. See just the first fraction as an example. You're never allowed to have 1 over 0. So if r was to equal the number 1, you'd have 1 minus 1 on the bottom, which would cause it to become a 0. So you can never have a 0 as a bottom of a fraction. So you'll see in the next question, Josh, right? You'll see this 1 over k plus 2. The 1 over k plus 2. If k was minus 2, what would happen to the bottom? It would turn into 0, wouldn't it? And then you're not allowed to have a 0 on the bottom. So you'll see for that question it says k is not able to be minus 2. And then for the next question, see the n plus 3. It says that if you had n is minus 3 on the bottom, it'll turn into 0. So once again it bans n from being minus 3. It doesn't affect you doing the question. It's just stating that the bottoms can't be 0. Okay. Now, if we were to take, I suppose we will take question 5 as an example. Part 5. Okay, I'll just rub out this part here. So part 5 as an example. Once again, which side will we take, guys? Left or right? They're both reasonably big, aren't they? Now, in general, it's always easier to put two fractions together than to separate one fraction into two fractions. Do you see that? If I chose the blue side, I'd have to separate one fraction into two fractions. If I choose the left side, I have to turn two fractions into one fraction. So it makes sense that once again I choose red, and I'm going to turn the red into the blue. Does that make sense? So what's going to happen here is exactly the same as what we did last time. What do you think we're going to do? Good, guys. We're starting to speed up. We're getting this now. This is good. Good sign. Right. Next. 2r plus 1. The minus 2r plus 1. All divided by 2r times 2r. 2r times minus 1. And then 1 by 2r. And then 1 by minus 1. Okay. Now look what happens to the top, guys. What happens to the top? I did. They're the same thing. Remember earlier where I said 1 over 2 minus 1 over 3, and you'd say multiply that one by 3 and multiply that one by 2. They're both 6, and then we join them into one big fraction. That's why we only need to multiply one of them. That was a good question. It's like a lot of people didn't know that, so it was a good question. 2r minus 2r. 1 plus 1. 2, and then this one, this one. Now, what way did I want it? We didn't even need to multiply it out, did we? Did we need to multiply it out that time? We already had it, didn't we? So we could just say it's 2 over 2r minus 1 and 2r. Basically what I had here a second ago. Yes, Connor? As an example, if I had oh yeah, I have a really good one for you, right? So 5/6 minus 1/3. Most of you guys will go, look, this is absolute child's play here. Multiply this one top and bottom by 2. Get 5/6 take away 2/6 to get me 3/6, which equals a half. Easy peasy. Not worth even thinking about, right? Now, let me show you another thing you can do with this, alright? Just another way of thinking about it, right? You would have never had to do this before. I'm going to change the 6. What am I going to change the 6 into? I've decided I'm going to change this, break the 6 down into its factors. 6 is the same thing as 3 multiplied by 2. Now, the 3 looks across, and it already sees another 3. So, the denominator is almost equal, isn't it? But what's not equal would be if I can put a 2 there. Now they're exactly the same. And I put a 2 on top, and now it becomes what we thought it would be. It's 5. And no, because it's already there. I didn't actually multiply it by 2. I just changed the 6 into 3 multiplied by 2. But the 1 over 3, I changed that by multiplying top and bottom. Okay, so what I'm going to get is 5 over 6 because I multiplied the 3 and 2 again, and that's going to be 2 over 6. Same answer as last time. 3 over 6 equals a half. Now, why would I do what I did there? Now, let me show you why I actually made this. Made you think a lot more about something that you've probably never really thought too much about before. Here's what happens. I look at this big. It looks like a reasonable monster of a question here. 5x minus 6 over x squared plus x minus 6. Take away 3 into x plus 3. Now, some people might try this. Alright? They might do this. Do you know what? If we put an x plus 3 top and bottom, do you know like we did in the last question? Yeah? And if we put a x squared plus x minus 6 top and bottom, that'll work, won't it? It actually will work, but it's extremely, extremely difficult. Okay? I've got a much easier way. Does everybody understand I did what we did in the last exercise? Just look across the your denominator, pick it, and use the top and bottom. Use the top and bottom. Here's a much easier way. Okay? So, what we're going to do is we're going to look at this one here, and we're going to factorize it. So what happens when you factorize it? 5x minus 6 divided by reference number, guys. What's the reference number? Sorry? Reference number is minus 6. Two numbers that will multiply to give you minus 6, but will add to give you 1x. 3 and minus 2. Answer, x plus 3, x minus 2. Like in the last question, the x plus 3 has a look over and goes, wait a minute, that one already has an x plus 3. We're very similar already. We're one step away from being the same denominator. What do I need to put beside the x plus 3 to make it the same as the one across the way from it? X minus 2, exactly. And x minus 2, top and bottom. And Rory, this is the question you were asking me about the 3 that time. Did I not need to put it on the top? The answer is no, because it belongs to the original denominator. Exactly. So now all of a sudden we have a much easier version of the same answer. So it's going to be 5x minus 6 take away x plus 6. Yeah. All over x plus 3 and x minus 2. Now what happens next, guys? 5x minus 3x minus 6 plus 6. Cancel. Just that's your answer. Are we cool with that? Okay. Everybody cool with that? We'll take that as a no. Look at this one. Question. Oh, 3 and 5 are tough, to be honest. 3 and 5 are both tough. Okay, so one of them has a trick in it, the other one is just a bit on the long side. Until I'm done. Okay, guys. So what we have next is part 3. Now, if you look at part 3 really carefully, 5 into 2x minus 3. Similar to part 1, we're going to factorize the bottoms where we can. So what happens when you factorize 2x squared minus 3x? What do you get? X brackets. Okay, minus 1 over x. Like in all the previous questions, all the fractions want to have the same denominator. How do we give them the same denominator? Thank you, x top and bottom for that one. The second one has everything already, doesn't it? The third one? And now all of a sudden, whatever answer you're going to get, it's going to be all over x into 3. So 5x minus 3, and then minus 1 is minus 2x. Thank you. And after that, 3x over x bracket 2x minus 3. Oh! The what? The x's? Is that what you're saying? What else will cancel there, guys? The x on the outside of the bracket and that x there will cancel because they're both multiplied by x. Now, Josh mentioned the 2x here. That 2x is in a more complicated position because it's inside a bracket. Oh, did you? Perfect. Sorry. So this x here can't be done because it's within a bracket. It's going to get multiplied by 2, and then the answer has 3 getting taken away from it. Well, the x on the outside of the bracket is a very simple x, just like I'm just multiplying. And the top one is like I'm going to multiply by 3. We're both multiplying, so therefore we're compatible for crossing off on each other. So the answer is 3 into 2x minus 3. Okay, so that one wasn't that bad, was it? It's okay. Now, next one. Yeah, this one. This one is this one's tricky. Okay, I'll show you there's a trick in here. Now, there's 2 ways of doing it. There's a really fast way and there's a slower way. We'll start with the slower, easier way. Look at this. 1 over x minus 1 plus x minus 1 all over 1. Do you see what I did there? Any number, like 5, 10, 15, they can all be written as 5 over 1, 10 over 1, 15 over 1, if you want. Okay. Just the whole point is you don't really even need to put the 1 there. It just doesn't even need to be there, okay? Now, what happens when you look across at the other one? What happens when you look across? What does this one want? What denominator does this one want? It wants the 1 minus x, top and bottom. What does this one want in the middle? It wants 1 minus x and x minus 1, which means on top it also needs the 1 minus x and x minus 1. Now, looks like a lot of multiplying, doesn't it? Do you know the fast way? Yeah, you can tell me in a minute. In Ireland we call that spoilers. It's like when you give away the ending of a movie. Okay, so what's next? Now, you can do this. You can multiply all that out. You can multiply that out. And you can multiply that out. And you can add the 3 red boxes to each other and get the answer. And somehow try and strike something off at the bottom. That's okay. And you may get the answer. Okay, so look, I might as well, what time are we at? I might as well follow it through now that we're here, right? So we'll just show you that you get the same answer. So you're going to get 1 minus x, and then you're going to get x times 1, x, x times x, minus 1 times 1, plus 1. Oh, sorry, minus 1, thank you, sorry about that. You're right first time. And then after that, minus 1 times x, plus x, okay? Now, stop here, I'm just going to add the two x's together, and what do we get? Does everybody see what I did there? Everybody see I added this x here, and this x here. Now, there's every single question here is all over the same fraction. Would everybody agree with that? Every fraction is the same, so realistically it's all one big line, and this thing here can move across. Okay, so now this part here is we agreed that it's a 2x, and now we have to multiply that by x minus 1. Then on this side we have minus x plus 1. Okay, now this man here is thinking, why is he doing it this way? Okay, we're going to get it out, but it's so much longer. Okay, so look what else happens. 1 minus x, now we got to multiply this out. So what happens? Anybody? 2x squared, yeah, minus 2x, yeah, x minus x cubed, yeah, plus x squared, yeah, minus x, yeah, plus 1. It's a lot of effort. Okay, now do a wee bit of counting here, guys, and the bottom still remains the same. Now we've already encountered quite a big battle here on this one, alright? Now look what happens. 1, 1, 1. Any other numbers on their own? No. So how many is that? 3. Minus x, minus x, minus 3x, minus 4x, minus how many x squareds? And then finally, x cubed. Now, this hasn't been done in your course yet, where you'd factorize this here, and what happen is one of them would cancel either one on the bottom. I don't know which one. You haven't gone that far yet, but if you're in your leaving cert, there's definitely a way of finishing that off. You just haven't done that part yet. Now, here's the really fast way. You go back to the very top, and you realize a little trick here. Okay, and it's so simple, you won't even believe it. Okay, so you go back to the very top. Now, we did nothing wrong. We actually didn't make a single mistake there. Our only problem is we didn't spot the shortcut. It's like if any of you ever played the old school Mario games where you'd have to go through all the levels, but then there was like a pipe that would bring you to the end of the game, or 5 worlds on. So you can spend a couple of hours playing your computer game, but you could have been there hours ago, okay, because of a shortcut. Here's the shortcut. If I multiply 1 over 1 minus x, if I multiply the top and bottom by minus 1, what happens? Does it change the value of the equation? What happens then? It turns into minus 1 over, and minus 1 plus x is the same thing as, anybody? And what does it look like a lot then? What does it look a lot like then? See this 1 over 1 minus x? That's what we had at the start, right? I'm now going to replace that. So this thing here is going to be replaced with this full part here. What happens when minus multiplies by minus? Plus. What you know is about the denominators now? They're exactly the same now, aren't they? So because they're exactly the same, we can say, look, x minus 1 on the top, x1 minus 1 on the bottom, x minus 1 on the top, and then you have a shortcut to the victory. You have a shortcut to winning this one. It's basically going to be 1 over 1 all over x minus 1. And then you're going to have plus, just going to multiply that out. x squared minus 2x plus 1 when I multiply it out, plus 1 at the end. Now what happens now? X squared minus 2x, 1 plus 1 plus 1, 3, plus 3, is it? Okay, you can't factorize that, and there's your answer. How much quicker was that? Because of that little shortcut. Now, I might try a question like this on you. I only have a second, Higgins, so I'll try and reiterate that point, so just give me a second. I'll give you a question like this. If I give you a question like this, anybody have any suggestions what to do with the second denominator? Top and bottom, and what happens? The bottom turns into, oh sorry, 1 second, yes, the bottom will turn into minus 2 plus x, which is the same thing as the minus 1 multiplies by the 3 to give you, and then all of a sudden this question becomes really easy because the answer is minus 2 over minus 1 top and bottom. What I recognise, Rory, is that see this denominator here compared to this denominator here, one of them is the minus 1 version of the other. So when I recognise that, I pick either one of them and multiply the top and bottom by minus 1 to make them into the same denominator. Okay.